This is 11.2.1 and 11.2.2, little mini lecture on your packet for geometry. This one it has all the skills that you've already learned in class, but you've never done a problem like this. There's a very nice diagram and explanation here. At first I felt too lazy, I didn't want to read the explanation. But really you should. Well, I'm going to go ahead and explain the explanation. Basically, we are able to use our geometry skills to find the distance between like cities on the globe. So we can find distances on a sphere now, because of all the trigonometry and things that we've learned this year. So there's only 3 problems that you're supposed to do. You need to always refer to example 1 to be able to do the 3 problems, because you'll notice that they have the information on Sacramento and Annapolis already on here. Okay, and there's a nice explanation here. I'm going to try to do problem number 1 with you together, and I'll keep referring back to this page because I can't draw as well as it's drawn on this page. Basically, our problem says Lisbon, Portugal is also 38 degrees north of the equator, but it's 9 degrees west of the prime meridian. How far is Annapolis, Maryland from Lisbon? When I first saw this, I was like, oh, there's no way. But now I see that Annapolis is we already have information on Annapolis because it came from the example. And they're just asking us a distance, and so we can do this. So I wrote down Lisbon. I got the, this is their latitude. Is that right? That's their latitude, and this is their longitude. Okay, and notice that their latitude is the same. So that's going to enable me to just find the distance between, or to find the angle measure between these. I'll try to show you on a picture what this is kind of, my picture, you can't see it at the same time. This is supposed to be a picture of the Earth. Okay, and this big R, this is the radius. That's supposed to be the center of the Earth, and this is right here the equator. Okay, so that's supposed to be on the inside of the picture. And then Lisbon's 38 degrees north of the equator, and so is Annapolis. So if this thing's the equator right here, then they're above the equator somewhere, right? And so in your book, they did a really good job of shading where they are. You can imagine that, I don't know if you can imagine with this horrible drawing, but imagine that this is a ball of clay, and I just slice off the top of it. Then I would have just this round circle here. That's the 38th parallel, and if you look at it here, look what a nice job they did. Okay, so if this is the equator, Lisbon and Annapolis are 38 degrees up. Okay, so then this right here is R, the radius of the Earth, which is, I think, 4,000, I think they said. Okay, so how am I going to do this? Well, I'm going to be looking at this shaded circle, and you can see they drew a little angle measure inside the shaded circle. So the shaded circle, I can just draw it, I'm just going to draw it flat like this. There's a shaded circle. Okay, that's just a cross section. I just grabbed this thing, and this right here, that's that. And then I can say, well, okay, so what's going on here? I'm just kind of turning it into like a coordinate plane, like maybe now it looks a little bit like our unit circle. And this is 9 degrees west, Lisbon's 9 degrees west of the prime meridian. So I'm just going to like just draw this little sketch. 9 degrees, maybe it's like that. 9 degrees. That says 9 degrees. And then just kind of making it look like a unit circle. And then this is 122 degrees. So 122 degrees, if I open from the, let's let this even be an axis. If I open up like that, well, all the way down to there would be 180. That's 90. So it's somewhere in here. that would be 122 degrees. Well, if I want to find the sector of the circle, actually what I want is this arc length right here. Well, that would be, I can get that by going 122 minus 9. So what's 122 minus 9? That looks like that's 113. So this degree measure right here, the angle measure is 113. Okay? 113 degrees. Now what do we do? Where is my... So now I'm trying to find this right here. Remember, I took it off of this cross section. It's actually, you know, looks something like, if that's the center or something. So you'd think I could just say, oh, well, this is, remember central angles, you can go like this. This is 113 out of a total of 360 degrees. And then I could just times it by the circumference of the circle, and we'd be there. It'd be all done. But the circumference of the circle is not so easy. This right here, that's not the radius of the circle. Well, it is a radius, but it's not the radius of the Earth. Because remember, the radius of the Earth is coming, it's more like, it's a little longer, it's 4,000. Okay, the radius of this smaller slice is going to be smaller. So I'm going to refer back to this diagram again. So, and if you read really carefully in here, you should be able to understand what's going on. This right here is the equator. I'll do it in pencil. Okay, this is that little cross section. This cross section right here. That's what this is. Okay, this is the radius of the Earth, which is, didn't they say it was 4,000 somewhere? I can't even see it. It says somewhere if you read all these words. Oh, there it is. It's right there. That's 4,000. That means this piece right here is 4,000. Right? Because it's from... Now, this is what we want. We want little r. If we had little r, we could just plug that in and we'd be done. So, I know this is 4,000, but look, I have a triangle. And guess what? This right here is 30, this little angle right here is 38 degrees, because it said it was 38 degrees north of the equator. And we have opposite, or what do we have? Parallel lines, alternate interior angles. So that means this little part right here is also 38 degrees. So you can't read any of that because it's too small. But I'm going to pull that out, and I'm going to put it right here. Let's see, I'll put it like this. Okay, so this is 4,000. I'm just drawing this tiny little triangle here. And this is 38. Okay, and then I want this. This is my little r that I want. I want 2 pi r. I want r to go in that spot. Because then I'll be done. I'll figure out the distance and it'll all be good. So, I put an X, I should have called it r. So which SOHCAHTOA? I'm going to use a SOHCAHTOA on it. I've got a degree, I've got adjacent and hypotenuse. So that's cosine. So I can say cosine of 38 equals adjacent over hypotenuse. Now I can go cross products will give me 4,000 times cosine of 38 equals, okay, so what is that going to be? I don't know. Times, that is this number. 3152. I'm just going to call it about 3152. Hey, I could have used that from the last problem, huh? Because they already did all that work, huh? Because it was 38 degrees just like this problem. Anyway, that's R. So now I'm going to go 3152. Now I have to multiply that by 2 and by pi and do all this division, put all this in my calculator. And actually, I'm going to let you guys put that in your calculator because my YouTube video is out of time.